So welcome back. We continue with more examples on solving second order homogeneous differential equation. Solve. So solve this differential equation. Solution. So let y equals to e raised power rx with a solution. So this means y prime is given by r e raised power rx and y double prime, which is the same as the second derivative, is r squared e raised power rx. So using these values, if I call this equation star, in star, we get where the second derivative replaced by r squared e raised power rx minus 8 r e raised power rx plus 15 e raised power rx equals to 0. So which means r squared minus 8r plus 15 e raised power rx is equals to 0. So auxiliary equation or characteristic equation so this implies that auxiliary equation or the characteristic equation is r squared minus 8r plus 15 equals to 0, since the exponential part cannot be 0. So solving, we can use factorization to solve this quadratic. So product is 15, sum is minus 8, numbers will be given by minus 3, minus 5. So that we'll have r squared minus 3r minus 5r plus 15 equals to 0. This pair, this other pair, common is r in this r minus 3, common here is minus 5, r minus 3 equals to 0. So which means r minus 5, r minus 3 are the factors. So therefore, r1 is 5 and r2 is 3. So which means that y1 is e raised power r1x, which is e raised power 5x, and y2 e raised power r2x, e raised power 3x. Now the general solution is y equals to c1 e raised power c1 y1 plus c2 y2, which will be e c1 e raised power 5x plus c2 e raised power 3x. Hence, the required solution is y of x is given by c1 e raised power 5x plus c2 e raised power 3x. Second one, find the general solution to the equation 2 dy d squared y dx squared plus 5 dy dx plus 3y equals to 0. And then second part, verify that your answer to part A satisfies the equation. Now, so as usual, we part A, let y equals to e raised power rx be the solution to the given equation. Let me call it star. So I say solution to the star equation. So this means that y prime, which is dy dx, is r e raised power rx, and second derivative is r squared e raised power rx. Now, using these values in star, we have, so just a matter of replacing y prime and y double prime in this given equation. So we'll have 2 r squared e raised power rx plus 5 r e raised power rx, then plus 3 e raised power rx equals to 0. So we'll have 2r squared plus 5r plus 3 e raised power rx equals to 0. And then here the auxiliary equation is 2r squared plus 5r plus 3 equals to 0, since the exponential part is not or cannot be 0. So product is 2 by 3, which is 6. Sum is 5. Numbers 2 and 3. Or you can use quadratic formula to solve the quadratic equation. So 2r squared plus 2r plus 3r plus 3 equals to 0. So this and this are the pairs. Common here is 2r into r plus 1 plus 3 into r plus 1 equals to 0. So 2r plus 3 into r plus 1 equals to 0. So this means 2r plus 3 equals to 0, and or r plus 1 equals to 0. So here 2r equals to minus 3, which means r equals to minus 3 over 2, and r equals to minus 1. So y1 will be e raised power negative 3 over 2x and y2 e raised power negative x. So therefore, the general solution is y of x equals to c1 y1 plus c2 y2. That means we have c1 e raised power minus 3 over 2x plus c2 e raised power minus x. So where c1 and c2 are arbitrary constants. So these are just real numbers. And then second part is now to show that what we have is indeed a solution. So B, we show that y equals to c1 e raised power negative 3 over 2x plus c2 e raised power negative x is a solution to 2d squared y dx squared plus 5 dy dx plus 3y equals to 0. So here, dy dx, so differentiating this will have negative 3 over 2 c1 e raised power minus 3 over 2x minus c2 e raised power minus x. And then the second derivative, differentiating this now will have minus 3 over 2 times minus 3 over 2 will have 9 over 4 c1 e raised power minus 3 over 2x. Now plus c2 e raised power minus x. And then, of course, y equals to c1 e raised power minus 3 over 2x plus c2 e raised power minus x. So if I call this one star, I call this one double star. Let's say replacing double star in star, we have 2 into second derivative is minus 3 over 2 positive 9 over 4 c1 e raised power minus 3 over 2x plus c2 e raised power minus x plus 5. First derivative is minus 3 over 2 c1 e raised power minus 3 over 2x minus c2 e raised power minus x plus 3 times y, which is c1 e raised power minus 3 over 2x plus c2 e raised power minus x. Now we don't conclude that it's equals to 0, but we show that after simplification, we'll get 0. So this will give us 9 over 2 c1 e raised power minus 3 over 2x plus 2 c2 e raised power minus x minus 15 over 2 c1 e raised power minus 3 over 2x minus 5 c2 e raised power minus x plus 3 c1 e raised power minus 3 over 2x plus 3 c2 e raised power minus x, which is equals to, collect like terms, we'll have 9 over 2 c1 minus 15 over 2 c1 plus 3 c1 and then e raised power minus 3 over 2x plus 2c2 minus 5c2 plus 3c2 multiplied by e raised to minus x. Now, if we say 9 over 2 minus 15 over 2, we get minus 3c1 then plus 3c1. This will give us 0 times e raised to minus 3 over 2x plus this will also be 0 times e raised to minus x, which is 0. So left hand side equals to right hand side equals to 0. Therefore, y equals to c1 e raised to minus 3 over 2x plus c2 equals to minus x is a general solution of the equation given. So that's how we confirm that that is the solution. Lastly, solve b squared y dx squared plus 8 dy dx plus 16y equals to 0. Now solution, let y equals to e raised to rx be the solution. So this means y prime is r e raised to rx and y double prime so with these values, this equation will be r squared e raised to rx plus 8r e raised to rx plus 16 e raised to rx equals to 0, which will give us r squared plus 8r plus 16 e raised to rx equals to 0. So this implies our auxiliary equation is r squared plus 8r plus 16 equals to 0, since r squared plus 8r, okay, since the other exponential part, is always non-zero. Now this quadratic product is 16, sum is 8, so numbers 4, 4. So I'll have r squared plus 4r plus 4r plus 16 equals to 0. So here we have r plus 4 plus r plus 4 equals to 0. So r plus 4 equals to 0. So r equals to minus 4 and minus 4. So this is a repeated root. So the general solution for repeated root will be y equals to c1 e raised to minus 4x plus c2 times x e raised to minus 4x. So that is how the solution will look like, or which can be written as c1 plus c2x multiplied by e raised to minus 4x. Thank you.